Okay. So we'll look at the last three here, see how we did. All right, 39. So we had to put together a couple concepts that this is, by the way, is from page 511, 6.1. 39, they're asking us to find a vector v, so we're looking for v, and theirs was bold, which means we need a little arrow over top of ours. So ultimately, I want to be able to find a vector v. And what they told me about v is that its magnitude is 2. So this is straight from the book. Magnitude is 2. And I kind of warned you about this, how like vectors in the book would be bold, but when we write them down, we put a little arrow over top of them. So we don't have bold font when we're handwriting. And then they also gave us a u vector and they gave us the actual vector 3, -3. And so we want our vector to be a magnitude of 2, and we want it to be facing in the same direction as this one is. There's a couple of ways we can do this. My preference would probably be to take this and turn this into a unit vector. So we practiced that in our notes, right? So if I took this definitely doesn't have a magnitude of 1, but if I could make this have a magnitude of 1 and be facing in the same direction, then I could just multiply that unit vector by 2, and that would grow it to a length of 2, and it would be facing in the right direction. So that would be my process. I'd try and take this and turn it into a unit vector. So in order to do that, I need to figure out what the magnitude of this is. I need to figure out how long this thing is. So I'm going to find the magnitude of u by doing square root of the x component squared, y component squared. That's 9 plus 9, which is 18, which is 2 times 9, so 3 root 2. Okay, why did I bother finding that? Because that's how long this vector is. I want to shorten this down so it's only a length of 1. So if I divide it by how long it is, then this would end up with a length of 1, a magnitude of 1. Okay, so I'm going to take the vector that they gave us, the 3, -3, and I'll multiply it by 1 over 3 root 2. And that'll shrink it down so that it's a unit vector. So that's going to be 3 over root 2. That's 1 over root 2, and -3 over 3 root 2. The 3's will cancel. That'll be negative, should be a comma, -1 over root 2. And I would probably want to rationalize those. So that's root 2 over 2, comma, negative root 2 over 2. So what do we do? This is the vector 3, -3, but I've not rationalized it. I've brought it down in size so that it's now a unit vector. So this has a magnitude of 1. And it's facing in the same direction as this. We want v to have a magnitude of 2 and be facing in this direction. So I can just take this and multiply it by 2, and that will grow it out so that it has a magnitude of 2. So I'll do 2 times what we just got there. And that's going to cancel these 2's on the bottom. We're going to get root 2, comma, negative root 2. How did I get what again?
How do you get the 1 over 3 root 2 now?
1 over 3 root 2. Oh, okay. Hang on just a second. I copied this down wrong. It was supposed to be a 2. That was bothering me. How did I get this? Okay. This, I figured out what the length of this was. The magnitude of this, and it was 3 root 2. Okay. So this thing has a length of 3 root 2, whatever that is. So it's like 4.5-ish, say. Okay, but we want to shrink it. We want to make it smaller. So we want it to be 1 unit long instead of 4.5 units long. So I'm going to take it, I'm going to divide this vector by the length of this vector. That'll make its length into 1. So I'm dividing by 3√2, which I'm accomplishing by multiplying by the reciprocal. Okay, so its length was too long. I wanted the length to be 1, so I'll divide it by the length, and then the length will be 1. Does that make sense? Does that answer your question? Okay. Other questions on that one? There's a lot of stuff going on there. If this isn't making a whole lot of sense to you, stay tuned. What we're doing today will probably help firm this up a little bit for you. Okay. Shall we look at 41? Yes, we'd love to. Cool, let's do that. So I warned you about this, that when they're talking angles, you got to be careful of the context. Navigation angles are going to be different from angles on the XY plane. We're used to measuring from the positive x-axis, and positive angles go this way and negative angles go this way. And this is 0, right? That's not always going to be true in these applications because, for example, in navigation, if you're talking about a heading on a plane or an airplane or whatever, or ship, instead you're going north, south, east, and west, and we always measure from north and we go clockwise. That would be a positive angle, and this would be a negative angle. Okay. How did I know that? When first time I did a problem that said heading, I looked at a Google search on what does a heading mean? And they gave me a little infographic that explained that to me. Okay. So let's see if we can figure out what's going on. So heading and bearing are the same thing. So an airplane is flying on a bearing of 335. So I'm going to sketch this is kind of like an XY axis, but it's also got north up here, south, east, and west. And we're measuring from north, so I need to go, what was it again? 335. So 90, 180, 270, 335 would be in this direction, someplace in here. How far from 360 is that? Huh? What? 335. Well, actually, it might be helpful to do this angle right here. What would this angle be right there? What would our reference angle be? 65, 75? Get a lot of blank stares. This is 0. This is 90. This is 180. This is 270. 335 minus 270 is 65. All right, there we go. And it's going 530 miles per hour. 530 miles per hour. So 530 is a scalar. So they gave us a direction and a scalar. So 530 is going to be the length of this vector. All right, so that's our vector. It's going in that direction, and they want us to find component form of the velocity of the airplane. So they want us to find an x component and a y component. So here's our x-axis and here's our y-axis. So what we're going to do is we're going to break this thing down into a triangle. So this is getting pretty small, so I'm going to resketch this triangle off to the side here. This is 65, this is 530. I need the x component and the y component. By the way, one of those is going to be positive and one's going to be negative. Which one's going to be negative? The x component, because it's to the left of the y-axis, and the y component will be positive because it's going up, right? So our x component is going to be negative. How are we going to find it? SOHCAHTOA. And I'll give you a little cheat code for this. Anytime you're looking for components, it's just going to be this times either sine or cosine of the angle. Which one do you suppose x is going to be, sine or cosine? Which one went with x when we were doing our unit circle before? cosine went with x. So the x is just going to be 530 cosine 65. And the y is going to be 530 sine 65. And then I just reach for a calculator. I type that in. Oh, I need to remember one of those is negative though. Which one was negative again? The x or the y? The x was negative, so I need to put a negative in there. Calculator's not going to do that for me. All right, I'll leave the button pushing to you guys. Any questions on 41? So if you didn't know what a bearing was, that could have set you back, but you guys know how to use Google, right? If you heard of this website, it's pretty awesome. You can like ask it questions, type in things that you're not sure about, gives you all kinds of answers. Yeah, it's cool. It's cool. Actually, there's other ones. I don't want to push, strictly Google. There's also Microsoft's got one called Bing. DuckDuckGo is an independent one. It's not. DuckDuckGo is one that's independent that supposedly is not spying on everything that you put in there. All right, number 43. Airplane is flying on a compass heading or bearing of 340 degrees at 325. Okay, this sounds very familiar. You know what? I think this is going to be the exact same problem with a different speed and a different angle. Oh, no, we're going to need to, this one's a little different. Okay, let's do this. We've got two things. We've got a plane and the wind. Interesting. So the plane is on a compass heading of 340. So I know that's in this quadrant here. This time, what's my reference angle going to be for 340? You guys with me today or what? What's my reference angle going to be? This is 270. Reference angle. I like to go back to the axis here. This is 320 to 270 is how far? 50? No, I'm sorry. It's 340. 340. 340 to 270 is 70. Okay, yes. Yeah, I see where you got the 70 from. And the magnitude was, how fast is this thing going again? 325. All right, guys, I'm doing too much of the work here. Grab your calculators and type some stuff in for me at least. The x component of this is going to be 325 times the cosine of 70, and the y component is going to be 325 times the sine of 70. Type those in, give me a, let's round to 1 decimal place. As soon as you get the x, go ahead and shout it out. Let's get this wagon train moving. Say again. 0.2 if we round. And then the y, same thing with sine instead. One more time. 305.4. Which one, should either of them be negative? The x should be negative because it's pointing in the left direction, and the y should be positive. Agreed? All right, we got the wind is blowing with a bearing of 320. So 320 is pretty close to this. And what's that going to make our reference angle? From 270 to 320 is 50. And it's going 40 miles an hour. So do the same thing again, except we're using 40 and 50. So 40 cosine 50 to find the x, and 40 sine 50 to find the y. Give me some values when you get them. 25.7 for the x, and 30.6. And tell me about sines. Are either of these negative? Which one? The x direction is negative. Okay. All right. So the plane's flying through the air, but then the air is also moving. So what are we going to do with these two vectors to figure out the actual movement of the plane? What do you think? We subtract them or do we add them? That's the question. So when the plane's instruments are telling you that it's this, that's moving through the air, but then the air itself is moving at this speed. I think we're going to add them together. It's kind of like the plane is on a map and the map is actually moving, right? So the map's moving this direction, the plane's also moving this direction. Those two things are going to kind of come together and actually make the plane move faster. Would you agree that the plane's going to move faster if the wind is blowing in roughly the same direction that it's traveling? So I think we're going to add to it. Yeah. If it was facing the other way, we would still add. It's just the signs would end up canceling it out and slowing it down. But when I look at this, I see the plane is moving in the Y direction positively, and so is the wind. So the plane and the wind together are going to be moving even more positively in the Y direction. Agreed? So we're going to add them together. So if you add these two vectors together, someone come up with our resultant vector. Help me out here, please. It's going to be negative. And 336. That's our resultant. That's the plane and the wind. Now it says find the actual ground speed in the direction of the plane. So now we're going to build a final triangle here. So both of them together are still going to be facing in that direction. I know because X is positive and Y is negative, or sorry, X is negative and Y is positive. If I make a little triangle here, the X component is 136.9, the Y component is 336. Do you think you'd be able to figure out the magnitude of that thing? It would be the length of the hypotenuse here. You could use Pythagorean theorem or the magnitude formula. Do you think you'd be able to figure out what this angle is right here? You should be able to, using an inverse tangent. And then the direction is going to be, remember we measure from north. So the final answer for the direction is going to be 270 plus whatever this little piece is here. So I'll leave that to you to finish up, but what you have left to do is you need to figure out what is the magnitude here. That's going to be your overall speed for the plane. And then you're going to need to use a little bit of right triangle trigonometry to solve for this angle here. And once you have that angle, use it to figure out what your direction is from north. Okay, were there any others from the homework that you guys would like to go over? 37. Find the magnitude and direction of the angle. So 37. Oh, I like this one. This is interesting. This is 7 times cosine 135i. That should be a vector I plus sine. Oh, I'm so glad you asked about this one. And this is all in parentheses. All right. This is a high concept question. Anybody want to tackle this one and explain it to us? We're looking for magnitude and direction. Anybody think they got it? One piece of it? All right. Well, let me give the answer and see if you can work backwards. The magnitude is 7 and the direction is 135 degrees. Now, can you work backwards and tell me why? If you ignore this 7 for a minute, if I gave you these values, say the cosine of 135 and the sine of 135, what are those two values? Where have we seen those before? in this particular context and order. Aren't those just the X and the Y coordinates for that point that's on the unit circle at an angle of 135? Isn't that what that is? Yep, they're the X and Y coordinates. So this is the cosine and this is the sine. We've talked about how the X and Y coordinates are the cosine and sine, right? And so if we thought of this as a vector at 135, how long is this vector right here? What's the magnitude of it? 1. It's the unit circle. So all of the vectors on this unit circle have a magnitude of 1. So this right here is a vector of 1 that's at that angle 135 degrees. Okay, but we're taking this vector with a magnitude of 1 and we're multiplying it by 7. How long is that going to make it? 7. So the magnitude 7 and the direction is 135 degrees. So they're trying to get you to make a connection that this cosine of 135 and the sine of 135, those are the X and Y components of anything on the unit circle. That's a unit vector right there at that particular angle. And then if I'm multiplying it by 7, that's going to stretch that angle or that vector out by a factor of 7. It used to be a length of 1. Now it's going to be a length of 7. We good on that? Thank you for asking about that one. That was a really important problem. Yes, yeah. So in 33, when they're asking for a direction, we can just look at it really quickly. 3, 4. We already know what the magnitude of that is, right? It's a 3, 4, 5 triangle. The magnitude is going to be 5. So if I think about this and I make a sketch of it, that's 3 in the X direction, 4 in the Y direction. We're talking about something like this, right? And the X component would be 3 and the Y component would be 4. And they want us to find the angle. And when we measure angle, unless they tell you otherwise, assume they're talking about angles from the positive X-axis. So I'd be looking for that angle right there. It's not 60. I would need to do, so the tangent of whatever that angle is would be 4/3. So to find it, I would do the inverse tangent of 4/3. And that will give you the angle, yeah. I'm assuming that if you've got a right triangle sitting in front of you with 2 sides, that you guys can find any of the angles in that triangle. Is that a safe assumption? That was a pretty large part of last unit. If that's not true for you, then please get my attention sometime. I'd love to spend some time making sure you got that. You're going to use it a bunch in this unit. Okay, let's move on to new stuff. Actually, there's nothing new today. We're just going to look at it through a different lens. So, this is where you're going to want your graph paper. So.